same old place that you laughed about. Well, the names have all changed.
Well, welcome back, my mathematical minions and minionettes. It's been a while, but as we look at this new semester, bring this in, we're going to start with an introduction to trigonometry. Okay, well, I know some of you are already crossing your head going, trigonometry, what are you talking about? This is geometry, Coach Maxwell. Well, it is, but trigonometry, if you look at this first part here, trigonomo, okay, this trigono, this means triangles. Okay, well, triangles, hey, that definitely deals with geometry. That's what we've been talking about. And this last part, this metry right here, means measurement. So trigonometry is the study of triangle measurement. So we're going to use this, and that's kind of our springboard for this semester. So as we look into this, we're going to start talking about trigonometric ratios. So we put that out there for trigonometric ratios. Now, we know from our earlier discussions that a ratio is nothing other than a fraction. So if we look at these, we're going to be looking at six fractions, or we're going to look at six fractions for each triangle. Now, we're going to start off with a right triangle, okay? So we're going to start off with this right triangle, and we know if we're looking at ratios for this triangle, if we're writing them out, how could we write out ratios? Well, let's see, and let's list all the different ratios we can come up with for this triangle real quickly here. This triangle here, if we were going to write the ratios of the sides, comparison of two sides here, these are the six different ratios that we could look at if we're looking at them. We could write it as 3 to 4, or 4 to 3. We could write 3 to 5, or 5 to 3, or 4 to 5 and 5 to 3. Or 5 to 4, sorry. So those are all six different ratios. And trigonometrically, as far as those are all six trig ratios that we're going to look at. And they all have names, and we're going to kind of go through those and look at those ratios and see what they are. And we're going to have to use them to be able to not only discern things about the triangle, but we'll be able to use them to find things about circles as well as we turn around and we lead forward. So first of all, let's start with this basic right triangle that we've got here. And we said that we know that 3, 4, 5 is a basic triangle. Well, there are six basic trig functions that we're going to deal with, okay? And those six basic trig functions. And trig functions, these trigonometric ratios, they all relate the angle to a side. So we've got to be talking about an angle here. So we're going to pick this angle down here, and we know from looking at this thing that we've got angle A, there's angle C, angle B here. We're going to use this angle B here. This is our unknown. So we're going to talk about this angle here. And when we start talking about, especially in trig, when we start talking about an unknown angle, you're going to hear me use, or see me use this symbol here. And this is the Greek term for theta. Okay, and that is the unknown. So that's when we talk about an angle. Here, our angle B, that's going to be our theta. And anytime we're talking about a trig ratio, we have to be talking about an angle. We're either talking about an angle by its letter, angle B, we're talking about the measure of an angle, a 32-degree angle, a 45-degree angle, or we're going to talk about some unknown angle that we're going to call angle theta. But anytime we talk about a ratio, as far as trig, we're always going to be talking about an angle here. So when we look at them, the six different basic trig ratios we look at are called sine, okay, cosine, tangent, cosecant, secant, and cotangent. Now, as you write all these down on your page here, and you're looking at them, as we start to say them, we start to write them, obviously there needs to be a shortcut, and there is. There is a shortcut for writing each one of these, and that's what we're going to look at. Let me show you the first one. So sine, we look at this one, this first trig function, sine. When we write it, we're going to write it not as sine, but we're going to write it as S-I-N. In this case, we're going to write it of an angle. So it's pronounced sine, not sin, okay? Not to be confused with what takes place on the weekends, but we're talking about sine. So we pronounce it as sine. All right, cosine, when we look at cosine, we're going to abbreviate that one as COS. And here again, we're talking about cosine of some unknown angle in this case. Tangent, we're going to abbreviate tangent as TAN. So we would find the tangent of angle theta. Cosecant, we're going to say cosecant is CSC of our theta. Secant is going to be SEC. SEC, not the Southeastern Conference, but SEC means secant. Secant of a theta. And then cotangent is COT. COT. Okay, so hopefully you've got all this written down, and you're going to need to be able to flip back to this and look what I'm talking about when we start seeing these abbreviations. But go ahead and get them written down, probably at the top of your page. You may want to write this on every page for a little while till you get used to seeing this and knowing what COS and all of these things are. So when we look at them, when we start to look at these things, we look at them in their comparisons. Because they're a ratio, they're a comparison of two things. They're a comparison of two numbers, okay? So let me erase this triangle real quick, and let's further elaborate on what these sine, cosine, and theta things are when we look at those, okay? Well, sine, cosine, and theta. We said that they're ratios. So the sine of theta is going to be equal to the length of the opposite side, the length of the side that's opposite that angle, over the hypotenuse. Okay? So it's the sine of theta. When we look at that one, it's going to be the side opposite to the angle over the hypotenuse. That's what that ratio would look like. The cosine is going to be the side that's adjacent to the angle over the hypotenuse. Okay? And by the way, I'm going to start abbreviating opposite as OPP, and hypotenuse is HYP, and adjacent is ADJ from here on out, just to save me time and to make things so that they're a little bit easier for you to see. And I would encourage you to go ahead and use that as well. But if you need to write out the words for right now, go for it. Now the tangent of theta is equal to the opposite side, the length of the opposite side, over the adjacent side. Okay? Now cosecant, which it's the opposite of sine. So it's going to be the sine up here flipped. It's the reciprocal of the sine. So it is the hypotenuse over the opposite. It's the hypotenuse, the length of the hypotenuse over the opposite. The secant is going to be the hypotenuse over the adjacent, because it's the reciprocal of cosine. And the cotangent is going to be the adjacent side over the opposite side. It's the ratio of the adjacent side over the opposite side. Okay, so when we look at these, that's where we start to put those in. So here again, get you a good table there on your chart. Start looking at these. Start memorizing these. It is important. You are going to be tested over these things each and every day for at least the next 2 weeks. You're going to have to know what these functions are. You're going to have to know the sine of theta is the opposite over hypotenuse, that the cosine of theta is the adjacent over hypotenuse, that the tangent of theta is the opposite over adjacent, that the cosecant of theta is the hypotenuse over the opposite, that the secant of theta is the hypotenuse over the adjacent, and the cotangent of theta is the adjacent over the opposite, okay? So if we look at these, as we further kind of expand on those things, if we were to look at a right triangle, which is what we're going to start doing, we're going to look at these and see how these kind of play out in a right triangle. So let's go back to this 3, 4, 5 triangle that I keep drawing over and over again. 3, 4, 5. And our theta here, this is going to be our theta, okay? So if we're looking for the sine of theta, if we're going to write this, the sine of theta, what would the ratio of the sine of theta be? Okay, well remember we said that sine is the opposite over the hypotenuse. Well, what's opposite this theta here? Well, opposite, if we look opposite it, this 3. This is the opposite for it. So sine is going to be, the sine of this angle theta is going to be 3 over, well, what's the hypotenuse? Well, 5 is the hypotenuse. So the sine of this theta would be 3 over 5. Okay, so what would the cosine of theta then be? Well, the cosine is the adjacent. Well, which one's adjacent? Adjacent means next to. So which one's next to theta? Well, now some of you are going, well, the 5's next to it. Well, no, the 5 is the hypotenuse. So if 5 is the hypotenuse and 3 is the opposite, there's only one that we can be talking about that has to be adjacent, and that's 4. So the cosine of theta then is going to be 4 over 5. Well, so what would the tangent of theta be? So remember, look back at your notes. Tangent is the opposite, which is 3, over the adjacent, which is 4. All right. Well, what would cosecant be? Cosecant of theta, what would that be? Well, cosecant, remember cosecant. It's the hypotenuse, which is 5, over the opposite, which is 3. Okay. So as we look at this, well, what would the secant of theta be? The secant of theta. Well, remember, this is the opposite of cosine. Well, if cosine was 4 over 5, this one's going to be 5 over 4 because it's the hypotenuse over the adjacent. And finally, the last one, cotangent of theta. Well, remember, it's the reciprocal of tangent, so it means it's 4 over 3. That's because it's the adjacent side over the opposite side. Okay, so looking at this one, there we go. So that kind of plays out here. Well, so let's look at this one in terms of, let's look at another example. So what if I give you another triangle, okay, and let's just go with 6, 8, 10. And just in this case, let's call this angle A and this angle B. Well, now let's play it out, make you think a little bit. What would the sine of angle A be? Well, look up here at angle A. Here's angle A. What's opposite angle A? Well, opposite angle A would be 8. So the sine of it would be 8 over, what's the hypotenuse? Well, the hypotenuse, it's the one that's across on the right angle. There's a right angle, so 10. 8 over 10. Well, trig ratios, we never leave a fraction. It's a fraction. We never leave it without simplifying it. So 8 over 10, we can do 2 goes into both of those. So this would reduce down to 4/5. So we would say the sine of A is 4 over 5. Well, what if I, instead of asking the sine of A, what if I ask for the sine of B? Ooh, well, hold on. Now we're talking about this angle down here. Sine is still opposite. Is it still 8 over 10? No, because 8 isn't opposite angle B. Which one's opposite angle B now? Oh, it's 6 over, what's the hypotenuse? Well, the hypotenuse is still 10. Can we reduce 6 over 10 down? Sure we can. 3 over 5. So the sine of A is 4 over 5. The sine of B is 3 over 5. So it's important that we pay attention to that angle. Remember we said sine, cosine, tangent, cosecant, secant, and cotangent only exist with an angle? Well, that's why you've got to pay attention. So if we looked at this, what would the cosine of angle B? What's cosine of angle B? Well, cosine, that's adjacent over hypotenuse. Well, angle B, adjacent. Which one's next to angle B? 8 over, what's the hypotenuse? Well, the hypotenuse is staying 10. It's a right triangle, so the hypotenuse is not changing. So 8 over 10, that reduces down to 4 over 5. Ooh, notice this. In this triangle, because in any right triangle, the sine of A here is 4 over 5. Well, the cosine of B is going to be 4 over 5. Notice those two are the same. Well, kind of an interesting thing there. When you start looking at the angles here, this is going to play out. Okay, well, this is the introduction to trig functions. We're going to go from here. We're going to find some more things about these later on. But right now, the important thing for you to know is that there are 6 basic trig functions. And they are sine, cosine, tangent, cotangent, cosecant, and secant. That they all exist. We find them for an angle. You need to know that trigonometry is the study of triangle measurement. Those are the important things for right now. So make sure you go over those, read those, make sure you commit that to memory, bring it back to class. I will see you when you get here tomorrow, and we will go on from here. Have a great evening.